everyone, welcome to my English garden, and today we'll be talking about Newton's laws of motion. So Newton has three laws of motion. First one, so we'll have Newton's first law, indicates that objects in motion will stay in motion in a straight line until acted upon by other objects, by another force, I'm sorry. The same way, an object at rest will stay at rest unless acted upon by a force. So if something is at rest, over some time, it'll stay at rest, doing absolutely nothing. All right, so the second law is basically the relationship between mass acceleration and the force acting on an object. The relationship is the force equals mass times acceleration. Mass is not the same as your weight. Mass is more or less what you're made out of, like the amount of matter you're composed of. Acceleration, again, is not the same as velocity, as we've talked about in previous videos. It's the change in velocity, that increment or decrease in velocity. That is acceleration. So basically, in more ways that you can write this out, is that force is actually the derivative of momentum. Momentum is just mass times velocity. So force would be derivative of mass times velocity. The way we do derivatives of things that are multiplying against each other, factors, things, is you take the derivative of one and times it by the other one, and plus the derivative of the other one times the first one. So it would be m derivative of v over time plus velocity derivative of mass over time. This might sound a little weird, the change in mass over time, which usually with kinematic problems, mass doesn't change. So then that would just be 0, and we will be just left with this side, which is just m times a, or change in velocity over change in time. However, when you have things like rockets, you do have a change in mass, for you use up fuel to power the engine, so you lose mass. That's where this comes into play. So this is like a little bit more extended version of F equals ma. Newton's third law is basically more or less just the most famous one, I would say, is that every force has an equal and opposite reaction. So it's, if you have two balls going at some velocity, they're supposed to be at a straight line against each other. Once they bump, that is going to cause a force. So this ball is applying some force to this ball. However, so is this ball applying a force to this ball. So this one is going to go flying out this way with some force, and they're just going to go back with some other velocity. The relationship between these two forces are that they are exactly the same. So that's why it has an equal and opposite reaction. The only difference is obviously the direction. So one would be positive and one would be negative once you have your established x and y plane. An example of this is when we have a box, let's say it's 500 kilograms. And we have some force acting on it this way, let's say 20 newtons, and another force acting on it with 30 newtons. In fact, let's switch it up to 25. So, assuming we want to know where the box is going. More or less, what's the force of the box, the final force? Or the total force? Well, we're assuming more or less, looking at the object, that it's going to go in this direction. So this is going to be at some angle. Just remind us of vectors. So this would be F. And just by observing the quantities of the forces, we can assume that actually theta is going to be larger than 45, because we have 0, 90, halfway point is 45, but there's more force acting on the y, so we can assume it's a little bit higher. All right, so now let's do actual calculations. So the way we describe the forces on the x and the y is by adding them. Not to each other, but the x's with the x's and the y's with the y's. So it's the sum of the forces in the x direction would be just 25 newtons equal max. Or just fx, we could leave it at that. The sum of the forces in the y direction are equal to 30 newtons. As we explained in the previous videos, if we have the x and y components of a vector, we can find the vector using the Pythagorean theorem. So f total, or rather just the actual vector, equals the square root of 30 squared plus 25 squared. This is going to equal 39 newtons. So that worked out. Now we want to find the angle. It's more or less the same process that we've done with kinematics. So we're going to use theta equals inverse tangent of y over x, which would be 30 newtons over 25 newtons. This is then going to equal 50.2 degrees, which worked out fantastically with our original assumption that theta was going to be larger than 45 because there was more force acting on it in the y direction than in the x direction. I hope you enjoyed Newton's laws. Check out other videos on my English garden, and I'll see you soon.